Well, that means for this problem, I need to be looking for something that is the bisector of it and is perpendicular to it. So let's take it in order. First thing I gotta do is find the slope of that original line. So step one, get the original slope. Now that we should be pretty good to go with at this point. We know slope is the rise over the run, or the difference in the y's divided by the difference in the x's. Things to do tonight, memorize that if it's not right smack front of your head. So slope, rise over run. So 10 minus 4, and now negative 5 minus 3. So this works out to be 6. This gives me negative 8. So that simplifies to a negative 3/4 as my slope. Who'd I lose? Okay. That bodes well. Step 2. Slope of the perpendicular line. Remember what we're working with here. I've got my 2 points, 3, 4. So here's 3, 4. Here's negative 5, 10. I'm going to be drawing a line through that that's perpendicular. So I need to have the line perpendicular. I need to know that slope as part of it. Well, if this line has a slope of negative 3/4, what's the slope of a line that's perpendicular to it? Close. It's not quite negative. It's not negative 4/3. It's what? 4/3. Yeah, if the original is negative 3/4, then the perpendicular, let's flip it around. I'm going to take the reciprocal and change the sign from a negative to a positive. So this new line here, the perpendicular bisector that cuts through this segment, which is 3, 4, and here's negative 5, 10, that guy right there is going to have a slope of positive 4/3. Now, step 3. I've got the perpendicular part, perpendicular bisector knocked out. Now I need the bisector part. So what point am I looking for? How do I find that spot right there? Remembering it's supposed to bisect that segment. What do you call that point? The midpoint. Do we have a formula to give me the midpoint of a line segment? Yeah, we did. It might have been a little while. And that's the average of the x's divided by 2, or the average of the x's, I'm sorry. Add them, divide by 2. And then the average of the y's. So you add those, and you divide by 2. Step 3, find the midpoint. So let's plug these values in here. So x1, that's 3. x2, negative 5, divided by 2. Comma. y1, that's 4. Plus y2, that's 10, divided by 2. So this gives me negative 2 over 2, which is negative 1. 4 plus 10 divided by 2, which is 7. Now in all of this text, let me bring out the important points. We've got the original slope, the slope of a line that's perpendicular, and we've got the midpoint. So the equation for this perpendicular bisector is going to have a slope of 4/3 and pass through the point -1/7, because that's the midpoint. That would be the slope of a line perpendicular. So what the last thing I can do now, step 4, write the equation. Now, as a review here, y minus y1 m x minus, that's point slope form. So let's plug everybody in. I have my original y. I know what the slope is. My x. Close parentheses. The slope is 4/3. Y is 7. X is -1. Yeah. If you're looking for the perpendicular bisector to the segment, yeah, I'm going to use perpendicular slope. Because this will be the slope of the line that's perpendicular to my original. Well, that's the downside. You won't get a diagram. It'll simply, the language of the problem, let's go back for a second here, will say perpendicular bisector. And that's how you know you want to work with the one that's perpendicular. But if you kind of think about what was in the original question, remember we changed the sign from -1 to +1 because in the original equation it's got that minus. The original question reads, find the equation in point slope form, there's point slope form, of the perpendicular bisector midpoint of the segment with the points, and then it gave us 2 points to go in, which let me use those 2 points to find the original slope, the perpendicular slope, the midpoint, and then put all of these 2 facts into my final equation. It looks like a lot, but it follows the formula very precisely. I give you 2 points, you give me the original slope, the perpendicular slope, the midpoint, and then blend those last 2 points into a final equation. It's drawing all of these things we've worked with, and now actually making you do something new and exciting with it.